Welcome to the Epic Flight Academy Commercial Pilot Course. Remember our 3 keys to success, and please hit that subscribe button. Our topic today is aircraft limitations, V-speeds, and the V-speed formula. Our primary reference today will be the 172S POH, the one with the NAV3 avionics option. Now, starting with the introduction of Section 2 on page 2-3, I want you to notice that Sections 2 and 9 of the POH have been approved by the FAA. That approval is what makes this a POH and not an owner's manual or an AFM aircraft flight manual. Review this in Chapter 9 of the PHAC with your flight instructor. Now, observing and complying with these limitations in Section 2 is required by the FARs. Anybody remember which one? Drum roll, please. And we find this in 91.9 paragraph A. So let's begin with airspeed definitions. These are found in at least 2 places, FAR 1 and in the POH Section 1. Shown here is an excerpt from Section 1 of the POH that defines airspeed terminology on page 1-10. You will need to study and memorize these airspeed definitions and review them with your flight instructor. Shown here is figure 2-1 from Section 2 on page 2-4. That defines airspeed limitations. The capital V stands for velocity, and the subscript defines the V speed, such as VFE and VA, etc. You'll need to study and memorize these airspeeds and review them with your flight instructor. Now, when you memorize the aircraft stall speeds, I want you to remember 2 things. Number 1, the aircraft stalls at its critical angle of attack, not at any particular airspeed. The stalling airspeeds we memorize are shown for specific aircraft conditions. Review these speeds in Section 5 of the POH and discuss them with your flight instructor. Number 2, V speeds change with the aircraft's weight. Now, this is not true for all airspeeds. Remember this, all V speeds will change with weight except for structural airspeeds. What are some structural airspeeds? Well, examples include VFE, VLE, if you're flying an aircraft with retractable landing gear, VNO, and VNE. An important airspeed to remember that changes with your weight is VA, or maneuvering speed. Now, maneuvering speed does not mean the speed at which we do maneuvers. We do various maneuvers, including turns, at a wide variety of airspeeds. And maneuvering speed does not mean that we cannot fly the airplane in the yellow arc on the airspeed indicator. So let's examine VA in a little more detail. The aircraft is designed and built to withstand a certain amount of stress or load. The amount of load the aircraft can withstand depends upon the category that it is certified in. Now, this is found in the POH in Section 2, page 2-11. If the aircraft was designed and built to meet the requirements of the normal category, it will withstand a positive 3.8 Gs with flaps up and a negative 1.52 Gs with no damage to its structure. If the aircraft is designed and built to meet the requirements of the utility category, it will withstand a positive 4.4 Gs with flaps up and a negative 1.76 Gs with no damage to its structure. An aircraft's structure is stressed by accelerating it. Now, this happens as a result of maneuvering by moving the flight controls, or it may happen as a result of turbulence. The more mass an object has, and in this case, the object is our aircraft, the harder it is to accelerate. The less mass an object has, again, our object is the aircraft, the easier it is to accelerate. VA, or maneuvering speed, is a speed calculated by the engineers when the structure is designed and built. Below this speed, the full deflection of one primary flight control in one direction, one time, will result in acceleration of the structure to its load limit, at which point the structure will unload. Well, now that's interesting. What causes the aircraft to unload? In other words, to not exceed its designed load? The answer is that VA airspeed that the engineers calculated. At this airspeed, the aircraft reaches its critical angle of attack while supporting this load, and the wing stalls. The stall unloads the wing. The stall literally reduces the G load, letting the structure drop back below its load limits. So, putting it all together, we can see that if our aircraft is lighter, it's easier to accelerate. So, because it's lighter, the aircraft will reach its designed load limit more easily. In other words, at a lower airspeed. So the aircraft reaches its critical angle of attack supporting this lighter load at a lower airspeed. Notice that VA speed is not marked on the airspeed indicator. Well, how could it be if it's always changing with weight? Now, please view our video on airspeed indicator markings. Well, if VA changes with weight, and my weight changes in flight, because we're constantly burning fuel, how do I calculate my VA? Well, simple. We use this formula. Now, let's say we have a scenario where we have a basic empty weight of 1,680 pounds, 20 gallons of fuel, and the IP, or instructor pilot, and SP, or student pilot, together weigh 340 pounds. So let's add this up, and our current weight is 2,140 pounds. So the formula looks like this. The formula says VA at maximum gross weight, well, for my airplane, that's 105, times the square root of my current weight, that's 2,140, divided by my maximum gross weight for this airplane, that's 2,550. Okay, let's do the math. And here we have it. 105 times the square root of that difference is 0.839, or 105 times 0.912. And the resulting answer is we get 96.189, or approximately 96 knots. This is our new lower VA speed. Now, here's an interesting tip. You can do this for any airspeed that is not a structural speed. For example, we can't use this formula for VNO, but what about VS? In section 5 on page 513, our POH tells us that the stalling angle of attack will be reached at 48 knots indicated airspeed if we are at the most rearward CG with flaps up and 0 bank angle and supporting a load of 2,550 pounds. In other words, maximum gross weight. Well, what if we're out flying and we're actually supporting 2,140 pounds at the most rearward CG with flaps up and 0 degrees of bank angle? What then? Well, what we can do is take the exact same formula. Will it still stall at 48 knots indicated? Well, let's do the math. Instead of 105 for VA, let's plug in 48 for VS. And here's what the formula looks like. 48 times the square root of our current weight, 2140, divided by our maximum gross, 2550, which gives us 48 times the square root of 0.839, or in other words, 48 times 0.916. And our answer, 43.972, or approximately 44 knots. This is our new lower VS speed. Well, folks, that wraps up our review of aircraft limitations and V-speeds. Join us next time.